Geologists need a big, strong hammer so they can break open the rocks to get a clean, unweathered face of the rock so they can look for the minerals. This is a typical geologist's hammer. The other thing geologists need is something to magnify the rock so they can see the very small minerals. So they use a hand lens or a mini microscopic thing like this. Here are some hand lenses and that little scope. Another thing they use is a magnet to test to see if the rocks are magnetic. There's one that's really magnetic. Look at that. That's a beauty. Geologists also test for hardness of minerals in the field using a knife blade or a special scribe. So let's test these three minerals here. We're going to use the pointy thing off the knife. And what to do first is you've got to find a crystal face. In other words, a nice smooth bit from the crystal, because that's where the hardness is tested in minerals. So we try to scratch along here. And you can see from this one it's not working. That's because that mineral, which is pyrite, has a hardness about the same as the knife. This one we'll try again on a crystal face. Nothing's happening, and that's because that's harder actually than the knife. This one takes a little bit difficult to find a nice smooth face we can scratch without destroying the thing. Let's give it a go with this. And you can see immediately, can you see that? There is a little scratch in there. You can see that there. So this is softer. That's because calcite, that's calcite, which has a hardness of 3. The middle one, the white one, that was quartz, that has a hardness of 6. Another thing they do is they take some acid with them so they can test to see if they have got a mineral that will react with acid. These minerals are typically things with carbonates in them. Let's test some rocks now. You'll see this is that acid. I'm going to drop it on this rock and you can see it fizzing. Look at that. So this has got calcite in it, which is not surprising because we expected this was going to be a limestone. Limestones have lots of calcite. In fact, they're mostly made of calcite. Let's test that again with some actual crystals of calcite. You can see the drop that's been put on there, that's bubbling away as well. So I'm going to add a little bit more and see what happens to it. Yes, you can see the bubbles there. They're pretty tiny, but you can see them. Another reason to have a hand lens handy. Okay, we're going to try a different rock. This one looks kind of sandy, but we're going to see what it is. Oh no, it's got calcite in it too. You can see that bubbling away quite a lot. Let's try another rock. What should we try now? I know, we'll try this ammonite fossil. Let's add a little bit of acid to that and see what happens. And that's pretty typical. You often find that fossils also have calcite mixed among them. But if we use this rock, and it looks a bit like that calcite before, but guess what? Can you see a fizz? I can't. So that's not calcite, that's something else. In fact, that's quartz. It doesn't fizz. Let's try this rock here, this metallic rock. No fizz again. So this is a very helpful tool. A little bit of acid to carry around with you. It's hydrochloric acid, fairly weak, usually only about 10%. It's enough though to give you a result you can rely on. Another thing that geologists and prospectors do or use is they use panning. Panning is a technique which separates minerals by their density. Okay, so this is a very important technique to help you understand what kind of minerals you're dealing with in the area that you're in. Here I'm just collecting some sample from a pile I have, and I'm going to pan it down using my little tiny gold pan. See this? Prospect is using for me. Got your pan of gravel. You take your pan of gravel and you're going to pan it down. All the heavy minerals, the more dense material, is going to go to the bottom. That's the point. Let's see. Not a lot of gravel. It's just the gravel we use to build things around the house. What happens to it? Okay? Wash it. It's called washing. For obvious reasons. Shake it, get it moving. Have a look. Some big rocks. Big rocks. Okay. This is how people can put gold, because gold's very dense. We'll definitely go to the bottom. I don't think we'll find gold in here. We might find something else that's different. There we go. You can definitely see those little rocks that have feldspar crystals in them. Once you wash them too, it's a good way for, especially doing this in the river, and you want to see what kind of gold you might be able to see. So just have a good look. It's a nice, fresh, clean material. It's an estimate. 30% is volcanic rock. 70% is sedimentary rock. To do that, so just put it up with my hand. See that? Can you see that? Is there enough light? We've got a big tail of stuff on here. Okay, I've got my handy dandy. I can have a look in here. So I can see better. Whoa. Definitely something inside. No, that little stuff stick to it. Yes. Go a bit closer. Can you see this? Okay. Can you see? If I go in here, you can definitely pick up a lot of this stuff. Put it on here, and it's hanging off. See the hanging off the end? That's the magnetite. So if this is magnetite, look at that. The rock is magnetic too. Enough magnetite in there. That also gives me a clue that this is probably an igneous rock. There's some other ones. Here's that one that's got the feldspar crystals in it. That's quite strongly magnetic. Look at that. Okay. You don't have to have a fancy one like this. Even a magnet on a string, a normal magnet, like we use in class. On a string, you can use that. Yeah. You can just feel it holding back. So then that's sensitive to that rock. That's one of the tests. Geologists sometimes use. Tiny rock with those big feldspars in it. Is it magnetic? Yes. Yes. Okay, there's enough magnetite mineral.